Hello, this is Susan Poss, and today I wanted to talk with you about rational exponents. And remember that the root word for the word rational is the word ratio. So you can look at my examples here and see that we're going to be looking at exponents that are in fraction form. So the first definition that you'll need to learn is when you have a base a raised to an exponent. In this case we're starting out with 1 over n, some number. Then the n assumes the position of the index number, and then you write down the radical, and the base and the numerator of that rational exponent becomes the power of the radicand under the radical. So when we're looking at, let's say we have a base 16, let's go with 16, and we have it raised to the power 1/2, what does that mean? It does not mean we're taking half of 16. It means that the index is this denominator 2. We write the radical, and this 16 then is the radicand with an exponent of 1. So I hope that you can see the numerator is this power, and the denominator becomes the index number. So that's all we're going to be talking about here, is how do you use these symbols. And of course the square root of 16 is 4. So you'll learn on your calculator, if you type 16 to the 1/2 power, for many of you that's just 16 with a little inverted v to the power 1 divided by 2, it will bring you to the number 4. So if you want to practice that with your calculator, you can do that. So here are my notes. The denominator of the rational exponent corresponds to the index of the radical. Okay, so here are the way the symbols look. Let's scroll down here and look at our chart. For square roots, if you have something raised to the 1/2 power, then it's the same thing as the square root of that same thing. If you have something raised to the 1/3 power, that's the same as the cube root of that base a. If you have a base a raised to the 1/4 power, that's the same as the 4th root of that base. And a base a raised to the 1 over n, which means any index number, then we just use the n value here in the position of the index. So you're going to see all kinds of different fractions in these rational exponent notations. So the first thing we're going to do is just do a little back and forth here, where we're looking at getting back and forth out of radical notation into rational exponent notation, or rational exponent notation into radical notation. These are starting out in rational exponent because you see a fractional exponent. We're going to take them to radical form. So 49 raised to the power 1/2 becomes the square root of 49. What happened to the 1 and the 2? Well, the 2 is understood here and the 1 is understood there. So for square roots to the 1st degree there, you don't need to worry about writing all that down. And of course the square root of 49 is 7. Over here we have 27 raised to the power 1/3. That is equivalent to the cube root of 27. And of course the cube root of 27 is 3. 3 times 3 times 3 is 27. We haven't done a 4th root before, so this is 81 raised to the 1/4 power, which is the 4th root of 81. You may have to pull out your calculator instruction booklet in order to find how to take a 4th root of something. And that number is also 3, because 3 times 3 times 3 times 3 is 9 times 9, which is 81. And the last one here, notice that there's parentheses around this negative 16, so I'm trying to take the square root of a negative value, and for now we're going to say no solution in the set of real numbers. We'll define complex numbers later on, and we'll have a solution for that. Let's go down here and do a cube root of a negative value. Notice the parentheses includes the negative, And so that means that the negative goes inside the radical, becomes a part of the radicand, and the cube root of negative 27 is negative 3. And the last one I wanted to look at with you is the square root of 36x cubed. And remember, the square root of 36 is 6. That comes out from under the radical. And then this square root of x cubed, we need to go to that process of writing that. It's an odd exponent. We need to write that with an exponent 1 and an even exponent here. So simplifying here further, the square root of x squared is x, and I cannot simplify. So I leave that in radical form. So all of those, if you'll notice, those previous examples, all of them had a numerator of 1. That was, in fact, in our definition with the numerator of 1. We're now moving into something where the numerator does not have to be 1. It can be any number that we need to have it to be. So we're talking about now both an m and an n, and you notice the m is up here in the numerator now. It's no longer a 1. So if we're working with positive integers greater than 1, and we want to put this in simplest form, then what we're doing now is we're going to put the radical notation out here. The n, again, the denominator becomes the index, and under here we have the base raised to the power. In reality, the way you're going to see me work these is you'll see me taking the root first, and then you'll see me raising to the power after I've taken the root. It just makes the arithmetic a little bit easier to work with the index part first and then go with the power later. So let's look at a couple of examples here. 9 to the 3/2 power. What does that mean? It means the square root. It means the square root of 9 raised to the 3rd power. Remember, there's a 2 understood there. And remember, I said I was going to do the root first and then raise to the power later. So let's get the square root of 9. The square root of 9 is 3, and then we'll raise to the power 3. And that brings me to the result 27. Okay, let's try. There's something I wanted to say to you about this one. Notice this negative is not included in parentheses like some of the previous ones were. So when it's not included in parentheses, it rides out in front. It doesn't get involved in going under the radical. So now I'm going to put the 256, and I'm not going to work it that way. I'm going to work it and let me see if I can figure out what the 4th root of 256 is. I'm not sure that I know. 4 times 4 times 4 times 4 is 16 times 16, and I know that that's 256. So don't lose the negative out in front. The 4th root of 256 is 4, and then we're going to cube that. So again, just so you'll see where everything is coming from. When I take the 4th root of 256, this is where that 4 is coming from. The negative is riding out in front, and now I'm going to cube to finish. Hold the negative out in front, and I think that is 64. So one more, and I think I can move on to something else. Here we're doing a 5th root of. So it's a negative value. Notice this is inside the parentheses, raised to the power 2/5. So on this one, I'm going to show you the 5th root of negative 32. And remember, I said I would work this by taking the root first and then involving the power later. So let me take the 5th root of negative 32. Which is negative 2. You can take an odd root of a negative value. So that gives me negative 2. Let me double check that. If I multiply negative 2 times itself 5 times, does that bring me back to negative 32? And I think it does. So here's 4 times 2 is 8, times 2 is 16, times 2 is 32. That would bring me to a negative 32. And now I'm going to square that. And it looks like my result is going to be 4. Okay, I think that's probably a good place to stop and let you practice some on your own. And we will talk about rules of exponents later.